Welcome to Thermodynamics lecture series. In the present lecture, we will discuss the concept of continuum. The term continuum is made by of two words which are continuous and medium. So concept of continuum is the continuum adjunction treats a substance as if it is made up of a continuous distribution of matter with no gaps or voids, even though matter is actually composed of discrete molecules, which means matter is considered as continuous distribution of mass with no holes or voids. In the schematic representation, we can observe the matter is composed of molecules and voids. But in continuum, we consider the matter with continuous distribution of molecules like this. So continuous distribution of molecules like this. So there is the no holes or voids. So in continuum mechanics, we treat materials as if they are made of a continuous substance, which means properties like density, pressure and temperature can be defined at every point and change smoothly from one point to another. In the macroscopic approach, we study the properties of matter by considering the average behavior of molecules at a specific region. So from the macroscopic viewpoint, we are always concerned with volumes which are very large compared to molecular dimensions. Let's consider the system which having the volume capital V and it is filled with the gas which having the mass is capital M. Then density of the gas is equal to the rho equal to M divided by V. Now consider a small portion of volume which is dou V and mass in the volume is dou M. Then density of the small portion is also same value, that is the rho, and rho equal to the dou M divided by the dou V. However, when the volume is small portion, that is dou V, which becomes very small and contains only few molecules, then the average density of this small portion is significantly varies over the time due to the random motion of molecules entering and leaving the volume. So here we are considering the very small portion of the volume. So only few molecules are presenting in the respected small portion of the volume. So number of volumes varies. So this small portion of the volume time to time, because molecules may enter or leaves the volume at a over period of the time due to the motion of these molecules. Then average density also varies. So it is impossible to speak of a definite value of dou M by dou V for the small portion of the volume. For a large volume, we can speak a definite value of the ratio M by V, but a small portion of the volume, due to the random motion of the molecules, we can't speak the definite value of the dou M by dou V. So we can't apply the macroscopic approach. If we plot the dou m by dou v against the dou v, then average density for a small portion will fluctuate up to a certain volume of the dou v dash. This is represented in the figure. Here we have to observe this figure. Dou m by dou v value is fluctuate with respect to the volume, and this fluctuation is varies with maximum to minimum, and this fluctuation is occur up to the certain volume, that is the dou v dash, and after that this ratio dou m by dou v is the stable. So when a smallest volume is less than this dou v dash volume, then dou m by dou v is fluctuate, and if we consider the smallest volume is greater than this dou v dash volume, then dou m by dou v is the stable and the concept of continuum is valid. So if we consider the smallest volume is greater than this volume of dou v dash, then concept of continuum is valid. Then density at a point P on a system is rho equal to the limits dou v tends to the dou v dash dou m by dou v. So this is the concept of continuum, and thank you.